have three objectives in this experiment. One, to calculate the probability of getting heads and tails by experimental and theoretical probability. Next, to record the possible outcome of getting a head or tails of 30 trials of tossing a coin. Last but not least, to find the difference between the experimental probability of throwing heads and tails and the theoretical probability of throwing it. Background study. Unknowingly, we use probability every day to make decisions about things that have uncertain outcome. In probability and statistics, experiments are conducted to understand how random events occur and how likely a certain outcome is. A simple example of a random experiment is flipping a coin. Although the theoretical probability of getting heads or tails is known, the actual result from a real experiment may differ due to random nature. This experiment involved flipping a coin 30 times, recording each result and comparing their experimental outcome with the theoretical probability. Through the activity, we learn how probability works in real-life situations and how experimental data can differ from expected value.
Methodology. The task assigned to our group is choosing a coin to produce random group trials. First of all, we divided the task among the group members. The members who were chosen to toss the coin will do their part first. The result that we will get from tossing a coin are either head or tails. The head will be labeled H, meanwhile the tail will be labeled T. We record all of this process in a video. The outcome from tossing the coin will be recorded. There will be a total of 30 outcomes. We will find the probability of getting heads or tails throughout the experiment. Therefore, we will continue to answer all of the questions given for the experiment based on the result that we collected.
As we can see from the table, the total frequency for head is 14 and the total frequency for tails is 16. The sample space for one toss is S equal to head, tail. The sample space for 30 toss, total possible outcome sequence equal to 2 to the power of 30. As 30 equal to all sequence of H and T of length 30. The head and tail that we got is head equal to 14 and tail equal to 16.
Experimental probability. Formula of experimental probability is number of times getting head or tail over total number of trial. Heads, number of times getting heads is 40. So, the probability of heads is 40 over 30 equals to 7 over 50. Or as 0.467. Tails, number of times getting tails is 16. So, the probability of tails is 16 over 30 equals to 8 over 15 or as 0.533. Theoretical probability. The formula of theoretical probability is number of favorable outcomes over number of possible outcomes. Number of favorable outcomes, head or tails is 1. Number of possible outcomes, head or tails is 2. Heads. The theoretical probability of heads is 1 over 2 or as 0.5, while the theoretical of probability of tails is also 1 over 2 or as 0.5.
The experimental results were slightly different from the theoretical probability. Theoretically, a fair coin has a probability of 0.5 for heads and 0.5 for tails, meaning both outcomes should appear equally. However, our experiment did not produce an exact distribution. This small difference can happen due to random chance because each coin toss is unpredictable. It also occurs because the experiment used a small sample size of only 30 tosses, which makes the result more likely to vary. In addition, human errors such as dosing technique, misreading, or recording mistakes may also affect the outcomes.
Now, I will show you a calculation for set 7. We have fx equal to 1 over 7 for 0 less than or equal to x less than 3, 1 over 7 x plus 1, 3 less than or equal to x less than 4, and 0 for otherwise. For question A, we have to find probability x greater than 3. So for the first step, we have to integral from 3 to 4 1 over 7 times x plus 1 dx. Next, 1 over 7 integral from 3 to 4 x plus 1 dx. After that, we can integrate x plus 1 and we get x squared over 2 plus x from 3 to 4. Then we substitute the value for 4 and 3. So we get 1 over 7 times 4 squared over 2 plus 4 minus 3 squared over 2 plus 3. So for the question A, we get 9 over 14. For question B, we have to find probability 1.5 less than x less than 3.5. So for the first step, integral from 1.5 to 3 1 over 7 dx plus integral from 3 to 3.5 1 over 7 times x plus 1 dx. Next, we can integrate the value and we will get 1 over 7x from 1.5 to 3 plus 1 over 7 times x squared over 2 plus x from 3 to 3.5. Then we can substitute the value and we will get 1 over 7 times 3 minus 1 over 7 times 1.5 plus 1 over 7 times 3.5 squared over 2 plus 3.5 minus 3 squared over 2 plus 3. And for the question B, we will get 29 over 56. For question C, we must find the value for mean and variance of x by using the formula. So for mean, the formula is integral from a to b x times fx. So for the first step for calculation is integral from 0 to 3 x times 1 over 7 dx plus integral from 3 to 4 x times 1 over 7 times x plus 1 dx. And then we will get 1 over 7 integral from 0 to 3 x dx plus 1 over 7 integral from 3 to 4 x squared plus x, and we can integrate. After integrate, we will get 1 over 7 times x squared over 2 from 0 to 3 plus 1 over 7 times x cubed over 3 plus x squared over 2 from 3 to 4. Then we can substitute the value and we will get 1 over 7 times 3 squared over 2 minus 0 plus 1 over 7 times 4 cubed over 3 plus 4 squared over 2 minus 3 cubed over 3 plus 3 squared over 2. And the answer for mean, we will get 61 over 21. We have to find the value for variance by using the formula, which is ex squared minus e of x squared. So for the first step for calculation is integral from 0 to 3 x squared times 1 over 7 dx plus integral from 3 to 4 x squared times 1 over 7 times x plus 1 dx. And then 1 over 7 integral from 0 to 3 x squared dx plus 1 over 7 x squared times x plus 1 dx. And then we will get 1 over 7 times from 0 to 3 x squared dx plus 1 over 7 integral from 3 to 4 x cubed plus x squared dx. After that, we can integrate. After integrate, we will get 1 over 7 times x cubed over 3 from 0 to 3 plus 1 over 7 times x to the power of 4 over 4 plus x cubed over 3 from 3 to 4. And then we can substitute the value and we will get 1 over 7 times 3 cubed over 3 minus 0 plus 1 over 7 4 to the power of 4 over 4 plus 4 cubed over 3 minus 3 to the power of 4 over 4 plus 3 cubed over 3. And the answer, we will get 781 over 84. And then, we substitute the value for ex squared and e of x squared into the formula of variance, and we will get 781 over 84 minus 61 over 21 square. And the answer for variance, we will get 1517 over 1764.
By conducting experiment 1, which is toss the coin, we were able to calculate the experimental probability of each outcome and compare it with the theoretical probability. Theoretically, a fair coin has an equal 0.5 chance of landing on heads or tails. In our experiment, after 30 toss, we recorded 40 heads and 16 tails. This gave an experimental probability of 0.467 for heads and 0.533 for tails. The results show a small difference from the theoretical probability, with tails appearing slightly more often than heads. Such variations are normal, as the outcome of each toss is random and small sample size can produce difference from expected values. From this experiment, we learned how to calculate the probabilities and interpret the result of random events. We also practiced listing all possible outcomes and understood that outcomes cannot be predicted exactly in each trial. Overall, this activity helped us gain hands-on experience in applying probability to real situations and improve our ability to analyze and compare experimental data with expected results.